students, welcome to Sonu Polity Physics class. Okay, today we will discuss about beta and gamma function. First, we discuss about beta function. See, beta and gamma function. Okay, generally we used alpha, beta, gamma as constant. Okay, students. Generally, alpha, beta, gamma are Greek letters which are used to denote the constants, which you use in our mathematics to denote the constants, like the roots of a quadratic equation, etc. But here in mathematical physics we use beta and gamma as a function. Okay, so first we discuss about the first function, that is beta function, then we will discuss about the gamma function. So today in this class, first we will study about the beta function. Okay, so see what is beta function. Clearly understand what is beta function. Beta function. First, see, it is defined by a definite integral. It is defined by a definite integral. See, what is that integral? That is beta mn 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So see, this beta function is denoted by, beta mn and read as beta mn. See, what is beta function? First, see, beta function is defined by a definite integral. What is definite integral? You studied. So it is denoted by beta bracket mn. Okay, this beta function is denoted by beta bracket mn. You can take xy, etc. Okay, so see, this definite integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Okay, this function depend upon these two variables, that is m and n, not upon the x. See, a very important things, that this beta function, which we denote as beta mn, this beta function totally depend upon this m and n, not on x. This is the most important thing for beta function. Beta function, again we say, beta function depends upon this m and n variable, not upon x. Okay, and it is denoted by beta mn and read as beta mn. Okay, this is the mathematical expression for beta function. So as we discussed this in mathematical physics, so why we discuss this beta function in mathematical physics? What is the use of beta function in physics? See, the use of beta function in physics. Okay, it used to compute to compute and represent the scattering amplitude of Righet trajectories. See, what is the application of beta function in physics? Firstly, it is used to compute or means to calculate and represent also the scattering amplitude of Righet trajectories. Trajectories विषय आमने projectile motion रे +2 फास्टर रे पढ़ीचे से Righet trajectory, that is a topic of quantum physics. आमे ते 5th बा 6th सेमेस्टर रे क्वांटम फिजिक्स विषय रे पढ़ीबा से क्वांटम फिजिक्स रे Righet ट्रैजेक्टोरी विषय देछि से Righet ट्रैजेक्टोरी रो एप्लीकेशन रे बीटा फंक्शन ना यूज हुए. सेकंड थिंग, see, it is also a symmetric function. Okay, so what is symmetric function? You also studied in your +2 in relation function chapter. So first we saw that this is used to represent the scattering amplitude of Righet trajectories. It is also a symmetric function. Okay, these are the application of beta function. Okay, so first we discussed that how we represent the beta function and what is the mathematical expression also. See, this beta function was first discovered by Euler and Legendre. Remember that this beta function was first discovered by Euler and Legendre, and it is also called as Euler's integral of first kind. Okay, it is also, beta function is also called as Euler's integral of first kind. Okay, and it was coined by Jacques Binet. Okay, students, so first we discuss that what is the application of beta function in physics. The first application is that is to compute and represent the scattering amplitude of Righet trajectories. Righet trajectories ro scattering amplitude को calculation करबा पाई बीटा फंक्शन नो यूज हुए. Righet trajectories विषय रे हमें क्वांटम फिजिक्स रे पढ़िबा. It is also a symmetric function and it was discovered by Euler and Legendre but coined by Jacques Binet. Okay, and it is also called as Euler's integral of first kind. Okay, you have to remember this. Okay, so these are the applications of beta function in physics. So now we will discuss what are the properties of the beta function. Okay, see, what are the properties of beta function? Properties of beta function. Properties of beta function. First, property number 1, that is beta mn is equal to beta nm. Beta mn is equal to beta nm. That is the first property of beta function. Okay, so देखो आर केमती प्रूफ होउची. So according to the mathematical expression of the beta function, so we can write, we know that beta mn is equal to, so see, according to the definition, by the definition of beta function, we can write that integration 0 to 1 x to the power m minus 1 minus x n minus 1 dx. Okay, by the definition of beta function, we can write beta mn, that is equal to 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. Okay, so we know a property of definite integral, that is by the property of definite integral, by the property of definite integral, we can write 0 to a f of x dx, that is equal to 0 to a f a minus x dx. We studied this property in class 2, that is by the property of definite integral, we can write a function as from 0 to a, that is equal to 0 to a f of a minus x dx. Okay, we can put this property in this beta function. Okay, so see, so when we put this, see, beta mn is equal to 0 to 1 x জায়গায় let দেখো এটি a জায়গায় কি আছে 1, in the place of a there is 1, so we can write here 1 minus x to the power m minus 1 c, and we can write here in the place of x we can write 1 minus x, so 1 minus x whole to the power n minus 1 dx. By using this property of definite integral in this beta function, we can write beta mn in the place of x. Here in the place of f of x we can write f of a minus x. Similarly, in the place of x we can write 1 minus x, so 1 minus x to the power n minus 1. Here also in the place of x we can write 1 minus x also, so see, here is also 1 minus x, 1 minus x whole to the power n minus 1 dx. So calculate this. So see, that is beta mn is equal to 1 minus x to the power m minus 1 0 to 1, sorry, here integration limit is 1. Okay, so here is also 0 to 1, 1 minus x to the power m minus 1, 1 minus x to the power m minus 1. Here see, 1 minus 1, that is, see, open this bracket, so we can write 1 minus 1 plus x to the power n minus 1 dx. Okay, next step, beta mn is equal to 0 to 1. Okay, 0 to 1, 1 minus x m minus 1. So see, 1 minus 1 cancel, so we can write x to the power n minus 1 dx. Okay, so here see, next step, arrange this function, that is 0 to 1. First write x to the power n minus 1, 1 minus x m minus 1 dx. Okay, so this is the last calculation. So when we say that beta mn is equal to, what we write, beta mn is equal to x to the power m minus 1 minus x to the power n minus 1. Here see, x to the power n minus 1 first, but here x to the power m minus 1, here x to the power n minus 1. So first we can write beta nn. See how this occurs. When we say about beta mn, here first is x to the power m minus 1, first m minus 1, and the second is n, so here n minus 1. But when we say about x to the power n minus 1 first, then here is the first n, then here m minus 1, so second one is m. So we prove beta mn, that is equal to beta mn. So we can write beta mn is equal to beta nn. That is proved. Okay. So see how we prove the first property of the beta function, that is beta mn is equal to beta nn. Okay students, so we can take screenshot of this. Okay. So then we will discuss about the second property of the beta function. Okay, this is the second property of the beta function. So see the proof of this second property. Okay, so see, by the definition of beta function, we can write that beta mn is equal to 0 to 1 x to the power n minus 1 minus x to the power n minus 1 dx. Okay, so here the proof is in 1 plus x form. So to bring this form into 1 plus x, put x is equal to 1 by 1 plus y. Okay, so take derivative of both sides, so we can get dx is equal to minus 1 dy by 1 plus y whole square. Okay, see, when from this relation we can get 1 plus y is equal to 1 by x. Okay, so when we put x is equal to 0, so y is equal to infinite. So when x is equal to 0, y is equal to infinite, and when x is equal to infinite, y is equal to 0. So when x is equal to infinite, then y is equal to 0. So limit can change from 0 to infinite, that is from 0. So when x is equal to 1, so when x is equal to 1 by 1, that is 1 minus 1, y is equal to 0. Okay, so we can change the limit from 0 to 1 to, that is infinite to 0. Okay, so see, that is beta mn. So put these values in this function. Beta mn is equal to, that is infinite to 0. So infinite to 0. Put this here, the value of x, that is 1 by 1 plus y, that is 1 by 1 plus y to the power m minus 1. And here also in the place of x we can put 1 by 1 plus y. So 1 minus 1 by 1 plus y to the power n minus 1 dy. Okay, no, dy minus dy by 1 plus y whole square. 1 plus y whole square. See again, these values we can put here. So beta mn is equal to, in the place of limit from 0 to 1 we can put, that is when x is equal to 0, y is equal to infinite, so we can place 0 infinite, and again when x is equal to 1, y is equal to 0, so in the place of 1 we can write 0, and in the place of x we can put 1 by 1 plus y, that is 1 plus y, 1 by 1 plus y to the power n minus 1. So here is also in the place of x we can put 1 by 1 plus y, so 1 minus 1 by 1 plus y to the power n minus 1. So in the place of dx also we can put minus dy by 1 plus y whole square, so minus dy by 1 plus y whole square. So by the definition of definite integral we can change the limit, that is 0 to infinite, due to this minus sign. Okay, so beta mn that is equal to 0 to infinite because due to this minus sign. Okay, so 1 by 1 plus open this bracket, 1 by 1 to the power n minus 1, we can write 1, so 1 by 1 plus y to the power n minus 1, because we know a by b to the power x is equal to a to the power x by b to the power x. So here 1 to the power n minus 1, that is 1, any power of 1, that is 1, and 1 plus y to the power n minus 1. Okay, so see, so again open this, that is 1 plus y, LCM 1 plus y nahi jao, 1 plus y minus 1, that is 1 1 cancel, so y by 1 plus y, so whole power n minus 1 achi, so y to the power n minus 1 and 1 plus y to the power n minus 1 also. See here in the place of limit from infinite to 0 we put 0 to infinite, that is interchange, because due to this minus sign we studied about this property in the definite integral in plus 2 class. Okay, so again in the place of in 1 by 1 plus y to the power n minus 1, we open this bracket as 1 to the power n minus 1 by 1 plus y to the power n minus 1, so 1 to the power n minus 1, that is 1. Again by calculating this 1 plus y taken LCM, 1 plus y minus 1, 1 1 cancel, so y by 1 plus y, so in the place of so when we open this bracket, so y to the power n minus 1 by 1 plus y to the power n minus 1. Here due to this minus sign there is limit change, so dy by 1 plus y whole square. See again the next step is beta mn is equal to 0 to infinite limit. So here see, here is 1 plus y to the power n minus 1, here is 1 plus y to the power n minus 1, here is 1 plus y to the power 2, that is n minus 1 plus n minus 1 plus 2. ऊपर कितना रहेगा, now y to the power n minus 1 dy by 1 plus y to the power m minus 1 plus n minus 1 plus 2. Here देखो 2 and minus 1 cancel, so here only the m plus n, so we can write here 1 plus y to the power m plus n. Okay, so see we also studied that is a property. What is this property? Now in definite integral from 0 to a f of f dx is equal to, we can write 0 to a f of y dy. By the property of definite integral we can write 0 to a f of dx is equal to f of y dy, because here x is a dummy variable, here y is also a dummy variable, so we can write that beta mn is equal to 0 to infinite x to the power n minus 1 dx by 1 plus x to the power n plus 1 n plus n. So the first one is proved. Okay, so we can take So you can take screenshot of this, then we prove this second function. Okay, so see, we studied a property that is beta mn is equal to beta nm, beta nm. So when we put this here, that is beta nm is equal to, so see here first term is n, so we can write here that x to the power, see, as beta mn is equal to beta nm by the property of beta function. So here we can write that beta mn is equal to x to the power n minus 1 dx, 1 plus x to the power n minus 1. So we can write beta mn is equal to also x to the power m minus 1 dx by 1 plus x to the power m plus n. So we can prove, so we proved that beta mn is equal to x to the power n minus 1, 1 plus x to the power m plus n, and x to the power n minus 1, 1 plus x to the power n plus n. Okay, so see the next, the third property of the beta function. So the third property of beta function, that is beta mn is equal to 2 into 0 to pi by 2 sin theta to the power 2m minus 1 cos theta to the power 2n minus 1 d theta. So see the proof of this third property of the beta function. Okay, so see the proof of this third function. So by the definition of beta function, we can write that beta mn is equal to 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx. So here we have to bring this function to this form. So we have to put, here is a 2 and here is a sin theta. So we have to put x is equal to sin square theta. So take derivative of both sides. Dx is equal to 2 sin theta cos theta d theta. Okay, so when x is equal to 0, when x is equal to 0, so theta equal to what? 0. Theta is equal to 0. So when x is equal to what? 1, so theta is equal to pi by 2. See, sin pi by 2 is equal to 1. So sin square pi by 2 is also 1. So when x is equal to 1, sin here theta is pi by 2. Okay, so we can change the limit from 0 to 1 to the 0 to pi by 2. So here we can write the limit 0 and here we can write the limit pi by 2. So when x is equal to 0, when x is equal to 0, theta is equal to 0. When x is equal to 1, so theta is equal to pi by 2. So see, put these values in this function. Okay, so put beta mn is equal to 0 to pi by 2, and here see x, that is sine square theta to the power n minus 1. So we can replace x as sine square theta. So sine square theta to the power m minus 1, and here we also put, that is 1 in the place of x. You can write sine square theta. So 1 minus sine square theta whole to the power n minus 1. In the place of dx, we can write 2 sine theta cos theta d theta, that is 2 sine theta cos theta d theta. Okay, again see beta mn is equal to, in the place of limit 0 we can write 0, and in place of 1 we write pi by 2 because limit change. So in the place of x we write sine square theta, that is sine square theta to the power n minus 1. In the place of here is also x, so we can write 1 minus sine square theta n minus 1 dx plus 2 sine theta cos theta d theta. So next step, so see next step, here 1 minus sine square theta, we can write cos square theta because sine square theta plus cos square theta is equal to 1. So 1 minus sine square theta is equal to cos square theta, and here 2 is also multiplied with n minus 1, and here 2 is also multiplied with n minus 1. So see beta mn is equal to 0 to pi by 2. Here sine square, here 2 is multiplied with 2m m minus 1, so this is 2m minus 2. So sine theta to the power 2m minus 2. Here 1 minus sine square theta is cos square theta, and from cos square theta 2 is multiplied with n minus 1, that is 2n minus 2. So we can write cos theta to the power 2n minus 2, and here 2 sine theta cos theta d theta. Okay, so next step is here sine theta to the power 2m minus 2. So here sine theta power 1, sine theta power 2m minus 2. So we can write beta mn is equal to 2 गोटे constant, so बाहर गण 2 0 to pi by 2 sin theta to the power 2m minus 2 sin theta to the power 1. So we can write sin theta to the power 2m minus 1. Here cos theta power 2n minus 2, here cos theta power 1. So we can write cos theta to the power 2n minus 1 d theta. Okay, so proved. Okay, so the third function, the third property of the beta function is proved. You can take the screenshot of this. Okay, these are the properties of the beta function. Okay, so in the next class we will study about the gamma function, the second function, that is the gamma